All right, let's take a look at the volume of cones and pyramids. Yesterday we looked at the surface area. Now let's look at the volume. So let's look at our cone. So our cone looks something like that. And yesterday we talked about the properties of a cone. There's the radius of the cone, of course, which is just the radius of that bottom circle. There's the height of the cone, which is that guy. And then there's the slant height of the cone. Okay? Remember, the surface area was pi r squared plus pi r L, where L is the slant height. The slant height is the distance down kind of the walled surface of the cone to the edge, where the height of the cone is literally just the vertical distance from the base all the way up to the top. The volume actually is really easy because it's just 1/3 pi r square h. Okay? And it turns out that for a cone and a pyramid, it'll be the same thing. Now again, not exactly the same, not 1/3 pi r squared h for a pyramid, but I'll show you what I mean. So then now let's look at a pyramid. Pyramids have very similar kind of vocab words, right? Let's put it there. Okay, let's draw this in blue maybe. Okay, so that's your pyramid, and the pyramid has the same thing. It doesn't really have a radius, but it does have half of a side length. It still does form that triangle. So in a square pyramid situation, this is the slant height down that triangle. This is the height of the triangle. And this would actually be half of the side length. So we also know that this is true, just kind of like it is over there in cones. We talked about the surface area yesterday was like x squared plus 4 triangles. I won't go right now into the whole how do you find the area of the triangle with the slant height stuff. But the volume of this guy is 1/3 x squared h. Okay, now let's compare these two formulas. 1/3 pi r squared h, 1/3 x squared h. And it turns out that for all cones and pyramids, the volume is just 1/3 times the area of the base times height. Okay, in a cone scenario, the area of the base, well, the base is just a circle, so it's that pi r squared. In a square pyramid, it turns out that it's just x squared. So hopefully you can see that in both scenarios, it's 1/3 times the area of the base times the height. So the volume for a pyramid and a cone is actually pretty easy. It's just 1/3 BH, where B is the area of the base. And this is still true even if you have some, crazy, hexagon prism, right? Or octagon prism, or not prism, pyramid. Now where we can, let's try to draw maybe there. Something like that. It's the same thing. The volume of that guy is 1/3 times the area of the base times the height, and the area of the base is the area of a hexagon, which you can do. Okay? There is a really small proof that this picture might not go very well, and if it doesn't, well then just completely ignore it. But if you draw a cube, I am doing my best to draw this cube. Okay, this is where it gets a little hard to draw. But if you take this cube and you connect these lines, we'll see if you can see it. So front, bottom left to back, top right, and that guy, and that guy. Okay, maybe you can see that down here, if you shade in that and you shade in that, can you guys see that like right sitting inside this cube is a pyramid that's got a square base? Okay, do you guys see that? And maybe visually it goes choo, 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 and you can kind of see that those lines intersect. Well, it turns out that the total volume, of course, is x cubed, right? But we know that if you take that and you flip it around, you can actually fit 6 of those blue pyramids in the cube, right? So if you take that pyramid and you put it on the left, on the front, on the right, on the back, and on the top, then that pyramid will fill the volume of the cube. Hopefully you can see how that pyramid only makes up 1/6. So this is the volume of the cube. The volume of the pyramid, then, we just proved that it has to be 1/6 of that. And if I rewrite this, I get 1/3 x squared times x over 2. And hopefully it makes sense that if the side length is x by x by x, the height of the blue cube is actually only half of x. So what we have is that I just showed you that if the cube is 1/6, if the pyramid is 1/6 of a cube, it's really 1/3 times the area of the base, which is x squared, and x over 2 is the height. So I get my 1/3 AH for this pyramid. Again, this pyramid is in fact 1/6 of the cube because you can stack in 6 of those pyramids to fill it. So if the cube is x cubed, the pyramid is 1/6 x cubed. 1/6 is really just 1/3 times 1/2. X cubed is x squared times x. X over 2 is the height. X squared is the base. And all of a sudden, I got the formula. Okay? The volume of any cone or pyramid is 1/3 BH.